Bismillahirrahmanirrahim. Assalamualaikum and very good day to everyone. My name is Muhammad Izzuldin Bin Roslan from UiTM School of Engineering in Mechanical Engineer. Today I'm going to present about my final year project 1, which is project proposal. The title of my final project is Evaluation of Optical Sensors for the Detection of Engine Oil Deterioration Level. Before I proceed, I would like to express deep gratitude to my supervisor, which is TS Dr. Rozina Binti Abdul for her patience and guidance and useful critique to help me in this project. I would also like to thank Dr. Zainal Helmi bin Solihin as course coordinator for his advice and assistance in keeping my progress in schedule. These are the key points of my presentation. My presentation will start with introduction, literature review, problem statement, then objective, scope and limitation, methodology, expected result, Gantt chart, and finally reference. For intro, recently there has been increased interest in monitoring the condition of lubricants facilitating proper engine operation due to electronic engine control. You can see that monitoring the condition of lubricants has become a critical technique for determining the state of equipment as well as the oil utilized in it. This is because each time the changing oil cycle occurs, the user will spend a cost for the changing oil. The longer the period of transition, the lower the cost to the user. Increased oil drain intervals can be implemented after first monitoring the engine oil condition. Furthermore, it gives a better understanding of the engine's current state, allowing for the detection of a potential engine problem as well as change in lubrication performance due to the use of different engine oil of various qualities. As a result, it's critical to obtain a sense of the proper change over time ahead of a time in order to make the best use of oil. In the current state of the art in the oil condition monitoring relies on algorithm aimed at determining the actual oil condition in an indirect manner. This is accomplished by analyzing driving characteristics. Some of these algorithms are currently backed by sensors that measure the permittivity or conductivity of the oil. The latter variables are linked to a variety of crucial oil qualities like water content and acidity. However, in addition to extending oil drain intervals, while also protecting the engine height against highly deteriorated oil, additional physical oil parameters must be considered. As previously researched, several online for oil contamination and condition monitoring are now being developed. These sensors have the potential to detect some of the most important indications of oil condition and contamination. They will also send real-time information to maintenance professionals, allowing them to take corrective action instantly. The chosen of optical color detection technology because engine oil darkens as its condition deteriorates with use. In the optical sensor, light is passed through the oil from one condition and recording of the intensity of the light absorption at the other end is done. The light source should have sufficient intensity to pass through the oil layer and strike the recorder with adequate intensity so that a slight variation in the transparency of the oil is sensitively recorded. Using an FTIR spectrometer, change in oil color can be attributed to viscosity, pH, and percent of transmittance. As a result, an online oil analysis technology is required to determine the accurate and precise condition of oil at any particular time. For my literature review, there are various research findings that I have found for the sensor that have been used for the oil deterioration and oil contamination. For the first one is by using microacoustic sensor by M. Fadlan in 2019. For the second one is quartz tuning fork sensor by Hausan in 2021. For the third one is temperature sensor by Manikandanji in 2019, and the last one is triboelectric nano generator by Junzhou in 2021. And the figure shown that every sensor picture that have been used in the research finding. To be more detailed in literature review, I will explain about the temperature sensor that used based on this finding. Based on this finding, temperature sensing is one of the most sensitive property parameters in the industry. In this experimental setup, the viscosity of the lubricating oil is easily found by means of the redwood viscometer apparatus. The temperature sensor should be installed in the engine's oil drainage port. The temperature sensor detects the temperature of the engine's lubricating oil. This signal will be sent to the microprocessor's control unit. The temperature signal are received by the microprocessor and should be converted into the viscosity unit by the processor by using a formula that they have been designed. Dynamic viscosity has been calculated theoretically using a redwood viscometer. When the viscosity value reaches the predetermined value, the processing unit gives the signal to the alarm unit. In turn, the driver or vehicle user knows the exact time of replacement of lubricating oil for the engine. From the result, it is shown that the temperature increase, the viscosity will be decreased. This article shows an approximate timing of oil engine deterioration when both set of value between measured and calculated are nearly equal. For the problem statement, this is due to always that need to check manually for the oil deterioration. It is not convenient for nowadays as it has many technologies that have been invented to be more futuristic and modern ways. Furthermore, changing the engine oil too soon lead to inefficient use of already depleted resources, as well as an adverse impact on the environment. As a result, most engine oil is discarded before it reaches the end of its lifespan. However, changing the oil too late may have an effect on the vehicle's performance. As a final result, in order to achieve a balance between these two considerations, the optimal oil change point must be defined. There are three objectives of this project. The first one is to construct the code program of the Arduino Uno R3 using Arduino IDE for monitoring of oil deterioration level. The second one is to develop an oil deterioration detector using an optical sensor. The last one is to differentiate and evaluate the performance of two different types of optical sensor for engine oil deterioration detection. For the scope of this project, I will be use a system that can monitor the level of oil engine deterioration using an optical sensor and Arduino microcontroller. In this project, I will use two different types of optical sensor which are TCS 3200 and ISL 29125. And for the limitation of this project is I will be use 5 engine oil sample with different period of use. And the second one is the I will not be use a moving process engine for the characterization and measurement. For the methodology, the first step is to gather all the information to get any relevant information about the oil engine deterioration and sensor that have been used in the previous research. After getting the information needed, the relevant information from previous research will be listed up as a literature review on this project. Next, the implementation of the Arduino software and installation of every component into the Arduino Uno R3. Then construct the flowchart of the system and convert it to the program code in Arduino IDE. As for the implementation of the software, Arduino IDE acts as a compiler that compiles the written source codes. If there is an error detected during the compiling process, there is a need to rewrite the coding before proceeding with the installation of the hardware component. After finishing the coding program, the component will be installed to the Arduino Uno RT to test and evaluate the data of this project. If any error happens, there is a need to do the troubleshooting to determine the error and resolve the problem that occur. Based on figure shown, I will be used two Arduino system. In figure A, I will use TCS 3200 and Arduino Uno R3 for one system. For the another system, in figure B, I will be used for ISL 29125 with Arduino Uno R3 and analog digital converter. For the experimental setup, the first figure shows the oil sample that I have been used in this project. For A sample is a new oil, for B sample is 1 week oil that have been used, for C sample is 2 month oil that have been used, and lastly for D is a 1 year oil that have been used. For the second figure is for the first analysis experimental setup. The first analysis method for this experiment is by using TCS3200 sensor. The oil specimen was set up on the box with the TCS3200 sensor faced to the oil specimen outside the oil container. The experiment test was held in the room atmosphere. The output of the system is the RGB, which is red, green, blue value. The RGB value of the color is represented by the 3 and 2-digit base hexadecimal value ranging from 00 to FF. But in this experiment, the RGB value will be analyzed in decimal value ranging from 0 to 255. The number 0 indicates no representation of the color, while the number 255 denotes the highest possible concentration of the color. The RGB value resulting from the optical sensor reading for all samples will be corrected with EV lux for further analysis. The expected result, the first one is all the oil sample will be tested in a universal litmus paper to determine the level of acidity and bases of the substance based on pH value. A universal indicator is a combination of several other indicators that can be used to approximate the pH of a sample substance. When the pH value is below 7, the substance is acidic, while the pH value that is greater than 7, the substance will be base or alkaline. For the substance that has a pH of 7, the substance will be neutral. Based on figure, the universal litmus paper has been soaked into the oil sample in this project. For the new oil sample, the pH value is 7. For the 1 week oil sample, the pH value will be decreased to the 6 value. For the third one, 2 months oil sample has a 5 pH value. Lastly, 1 year oil sample has a pH value with 4.5. For the second result, the graph shows the RGB value detection from the TCS3200 with the time taken for every oil sample condition. From that, it shows that the higher the pH value, the higher the output of the RGB value. For this slide, I will present my Gantt chart for this final year project. My project activities is collecting information, problem statement, list up literature review, identify methodology, circuit design and configuration, write coding using Arduino IDE, implementation of hardware, testing and evaluating, troubleshooting, and lastly logbook and thesis and technical report. This project planning is good for us to see and reflect the schedule of our project in this semester. In this slide, there are several articles or journals that I have been used to finish this final year project. That's all for my presentation on proposal project. Thank you for having a time to hear and give attention to my presentation. If anything happen or have a question want to ask, you can call me on the phone or email me. Thank you.